Well, first off, thanks for having me. And a bit of a background. Every Sunday, I like to sit with my family and have a traditional Sunday roast. And sometimes I have beef, sometimes I have lamb, and sometimes I don't have any meat because that week it's chicken, and I really can't stand chicken. But actually, it doesn't matter what type of meat I'm eating. I know that I have some role to play in conservation through what I choose to eat on my Sunday roast. Or if you want a more sensible title, I'm going to be talking about the impacts of different grazing management on invertebrate conservation and calcareous grasslands. But I need to give you an apology. I will not mention the Burren once after this point. I've never been to the Burren. This is my first time. It's a bit like Disneyland for calcareous grassland ecologists. So I'm having a great time. And of course, I don't need to tell anybody in this room or even online the importance of calcareous grasslands, or that they hold the world record for the most number of species in a square metre if we're thinking about plants, but also they're incredibly diverse in terms of their invertebrate fauna too. And in order to maintain this fabulousness, they require careful management. And that's not something that they've always had. Across Europe, changes in agricultural management after the Second World War has resulted in dramatic loss of both plant species richness and the associated invertebrates, and large areas of calcareous grasslands have just been lost. The EU Habitats Directive affords it, or should afford it, some protection going forward. And just to put into context how much exists within Europe, there's close to 600,000 hectares. As a local context, in Ireland, the most recent figures I can find are that there's close to 3,500 hectares spread over 35 sites. If we think of a much larger country such as Germany, it has about 10 times that amount, but spread over 924 sites. And it's worth remembering that just for later on in the talk. And then if we look at the UK, so that's including Britain and Northern Ireland, there are around about 33,500 hectares, so comparable to that in Germany, but these are spread over 62 sites. And of that occurs in the United Kingdom, 60 to 75% of that is found in upland Britain, so really important for the extent. But unfortunately, like much of Europe, calcareous grassland faced decline, mainly due to intensive grazing, and there was a 37% loss overall between 1960 and 2013. Then we had some changes. Foot and mouth disease in 2001 eradicated 4.9 million sheep from the national flock. Then we had Common Agricultural Policy Reform in 2003, which changed payments from a headage system to an area-based system. And this resulted in these types of grassland in a reduction in grazing intensity. And among conservation managers, there was this shift away from evil sheep to grazing with a low intensity of cattle. But at the time, other than plants, the impacts on overall biota were relatively unknown. So we tried to change that by providing some sort of evidence base. So the first project we did looked at the impacts of 3 grazing types on plants and carabid beetles. We had to include plants because that's the language that lots of conservation bodies speak. So that was our gateway in, really. So we looked at low-intensity sheep grazing, low-intensity cattle grazing. I was worth noting that they were a comparable intensity, and areas with no grazing at all. And we asked a number of questions. So does plant or carabid beetle species richness differ? Does the composition of these differ? And actually, can we use plant species composition to inform something about carabid beetle species composition? Because on the ground, often plants are more readily recorded than invertebrate groups. So we had 3 locations across northern England. We had our replicated grazing treatments in these 3 locations. We had that 3 times, and in there we had 3 sampling plots. Within each of those, we had 5 pitfall traps that ran for the length of the season, and we paired this with 2x2 vegetation quadrats that, again, ran throughout the season, so we had a full time span. And what we found in terms of the plant species richness wasn't a great surprise. We had comparable plant species richness in each of our cattle and sheep grazing treatments, and a reduced species richness in our ungrazed treatments. When we looked at the carabid beetles, we found actually species richness was comparable across all of them. The interesting thing is when we start looking at the composition of those communities, and this is a complicated ordination, don't worry about it, it's easily explained. What we find here is 2 different assemblages. we find the green squares, which is the sheep grazing, and the yellow triangles, which is the cattle grazing, have overlap in that assemblage, but our blue circles, which is our ungrazed area, have a distinct composition. And that was the pattern there for plants, but we had the same pattern occurring for ground beetles as well. So essentially in these areas, we have these two distinct assemblages. And then we did something called a procrustes rotation. It gives you this really, really ugly graph, and it makes no sense. Don't worry about it. That actually makes much more sense. The important thing is the number at the bottom there, so the 0.42, and if you're a statistician, you're saying that actually this correlation is significant, but we're not just statisticians, we're ecologists, and we need to put this into the context of ecological processes. And actually that 0.42 is a bit low. We want that to be closer to 0.7 or 0.8 to be able to say that actually from the plant composition we can infer something about carabid beetle composition. That's not my dog, by the way. I've never met it. And then we looked at species that were associated with each of those grazing treatments for both plant and ground beetles. And we found a large number of, a large 7 species of plants associated with cattle grazing. And when we interrogate that and look at what those species are, it starts to give us information. Now, don't worry if you're not a botanist, the name of it doesn't actually matter. The thing that starts to make more sense is the clonality. So how do these things spread? And we found that in the cattle graze treatments, we started to get species that spread vegetatively through rhizomes. So essentially a cow tears up a patch of grass, or it leaves a big massive cowpath behind and it becomes bare, and those species that can spread by rhizomes start to pop up. Unsurprisingly, in the sheep grazed areas, we found a tussock forming grass. And in those no grazed areas where there was no such thing as light at the ground layer, we didn't have any of that vegetative spread. And then the 3 ground beetle species we found associated with, probably safe to say all invertebrate species are declining, but the 2 notable carabid species are known to be in a fairly vast decline. So at least we're providing space for these large ground beetles. So to summarise, plant species richness does differ among grazing treatments, but carabid beetle species richness doesn't. We get 2 distinct communities of both plant and carabid beetles, but composition can't be used to indicate what's going on with carabid beetles. So then we moved on to our second study, and we started to look at a little bit more interesting of a group. That's my own personal bias. And this time we wanted to look at spider responses to vegetation structure, and using the same grazing treatment, but with the addition of high-intensity sheep grazing, because in these landscapes that still occurs on calcareous grasslands. Now, we know from the previous study that plant community is impacted by the type of grazing, and this might subsequently impact upon vegetation structural complexity. I know that from my legs. So when you walk through these high-intensity sheep-grazed areas, it's like walking through carpet. It's so lovely. But then as the grazing starts to be reduced, it gets more difficult. So where grazing happens, you get this more structurally complex sward. And then when you take grazing away, it's like walking through mud. And of course, vegetation structure is really important for spiders, because where you have high structure, you provide anchorage points and foraging niches. There's differences in prey availability and also cover. Whereas open habitats might favour shade-intolerant species or ones that are really good dispersers. So this time we asked some different questions. I mean, would the statisticians tell us that vegetation structural complexity does differ? You know, are my legs lying, am I just unfit? Again, does spider species richness differ? And this interesting one, does spider gill proportion differ? So the way in which the spiders hunt, and does that differ among the communities? And does spider assemblage differ? Same sort of sampling method, but this time to measure vegetation structure, we were dropping a pin into the ground and measuring the contact points of vegetation of 5 centimetre increments, and the total number of contacts gave us this unit of structural complexity. And we split our spiders into different guilds. We had the ground hunters, the sheep web weavers, the space web weavers, the orb web weavers, and this group that Cardoso calls others, ones that don't fit neatly into any sort of group. And actually we found with the vegetation structure, your legs don't lie. It's exactly as we expected. Where you have high intensity grazing, it's low structure. Where you have no grazing, it's really high structure. And where you have intermediate grazing, it's intermediate structure. When we looked at species richness, despite spiders being more speciose than carabid beetles, we couldn't disentangle any sort of relationship there. So actually probably not a good proxy for measuring differences in these places. But then when we looked at the gill proportion, we started to find interesting things. So the light green, which is the bottom here, we found actually that the proportion was lower in the high intensity sheep grazing for the sheep web weavers, so things like most of the money spiders, than it was in any of the other grazing types. The ground hunters, which is that slightly brighter green, we couldn't compute the GLMM on because of lots of zeros in the data for the high intensity sheep grazing, but I think it's fairly safe to say that we have a much lower proportion of ground hunters there. And this seems to be replaced by this group of other hunters. Now again, if we look at what those species actually are, before we get there, looking at the assemblage differences among these, we find this time 3 distinct communities. Just note that the y-axis is a fairly low proportion of the data set, so it's the horizontal relationship we're looking at here. The red diamonds, which is the high-intensity sheep-grazed areas, have a distinct assemblage. The blue circles, which is the ungrazed areas, have a distinct assemblage, and we have this shared assemblage among that low-intensity cattle and low-intensity sheep-grazed areas. And then if we look at the species that make those up, so these are the species associated with ungrazed areas, and again, don't worry about the names of the species, it doesn't really matter. But what matters is the pattern in habitat preferences. Those associated with ungrazed areas, generally speaking, like moist, stable environments that aren't disturbed very often, and they're quite like a fair bit of leaf litter in there. When we look at each of the low-intensity grazed systems, we start to find that we get more grassland-associated species where they don't mind a little bit of disturbance, but they still like some dampness in there. And then, really interestingly or not, if we look at those species associated with high-intensity grazing, we find a really boring community. It's ubiquitous, they're things that disperse really well, there's some shade-intolerant species, but a community you're likely to find in any crappy old overgrazed grassland. And then if we look at conservation interest in there, we actually find in all of those grazing treatments some species found within them. So we find 2 species listed as endangered, Jacksonelka falconeri, across all of those grazing types. And really interestingly, this second one here, poor Homerigeria, we find only in our ungrazed areas. According to the literature, this is usually a cave dweller, so perhaps an association there with exposed limestone pavement coming out into completely undisturbed grassland. Okay, so to summarise, yes, vegetation structural complexity does differ. I'm not that unfit. Spider species richness doesn't differ among these grazing treatments, but the way that the hunting strategies make up those communities does differ, particularly for the high-intensity sheep grazing, and this probably explains the differences in species assemblage too. So then we wanted to move on to something even more interesting, again using spiders as our way of investigating this, but in these calcareous grasslands, much like the ones here in the Burren and elsewhere, it's not a completely lovely homogeneous habitat. There's patches of heterogeneity in there, so what you'll often find are these areas of limestone pavement, but where you've got deposits of glacial till, you have acid grassland or heathland coming through there. So this time we wanted to assess these areas that, I mean, this dry heath is also an Annex 1 habitat, but it's not actually targeted within a calcareous grassland matrix by conservation, they just are there. So what's happening in there? What conservation interest do these have? So this time we looked at just low-intensity sheep-grazed systems because that's where you seem to have the good development of heather. And this time we looked at calcareous grassland, acid and heath. There's no limestone pavement in there because I couldn't really get a pitfall trap in any of those. So asking similar sort of questions, but getting rid of species richness because that turns out, you know, not to tell us too much. Does assemblage differ? Does the way that these spiders hunt differ? And do non-target habitats by conservation actually support species of conservation interest? So again, a similar sort of setup with pitfall traps, this time having within site replication as well as external replication of each of those habitat types, and spacing them a fair distance away so that we weren't biasing our traps. And what we actually found, again, the y-axis relationship doesn't tell us too much. The horizontal relationship is the interesting one. We found two distinct assemblages, a completely distinct one in heather patches, but our grassland types shared this assemblage. And again, looking at those gill proportions, we started to find some interesting things about those assemblages. So again, sheep web weavers at the bottom there actually differed in proportion among all of those habitat types, and accidentally really neatly going up in proportion across the graph. Then when we looked at the ground hunters, we had a lower proportion in our heathland than we did in our grassland types. And then we have, differences in proportions of other hunters, but not statistically different in any way. So it seems that in our heathland, our sheep web weavers actually provide more of a proportion than our ground hunters, and that's where the change in relationship happens. And again, when we look at species of conservation importance, we find the same sort of species we found in the previous study, but really interestingly, we find poor homogeneity again. Now, we didn't find that in the calcareous grassland study previously in the low-intensity sheep-grazed areas. We found this here only in heath areas. And in these places, grazing intensity is low enough that the sheep don't bother too much with the heath. So again, that's acting as an undisturbed sort of habitat. So perhaps I suggest, there's not very many records of this at all externally, but maybe it prefers really undisturbed habitats rather than just being associated with caves. But again, a number of species of conservation importance occurring across all of these habitat types. So yeah, our spider assemblage differs, particularly with this difference in heath areas. The gill proportion differs, and that tells us something about how these communities are made up. And absolutely, these non-target habitats, ones that conservation management is just sort of left to just happen on their own, do support species of conservation interest. So, taking all that information, we actually wanted to make it applicable to people who might be able to use it. So we wanted to make some management recommendations, but in order to do that, we posed them a question, actually, what do conservation bodies want? Or, to make this more relevant to today, what meat should I have on my roast dinner? So, if we're after distinct species compositions, there's an argument to say, just go for whatever, have lamb every week if you really wish. But remembering that actually that composition was a bit rubbish, we'd say sometimes have beef, sometimes have lamb, and sometimes have nut roast or, whatever you have as a different option. And then thinking about in those areas of low-intensity grazing, we'll keep the calcareous grassland, you can't get rid of that, and we'll keep those heath patches. And could we actually try and promote successional processes in those acid grassland patches so they become more heathy, because then we get more of these and distinct species assemblages. But what if we want to protect rare species rather than, just composition? Well, eat some beef, eat some lamb, don't eat, eat some nut roast. But then this time, in that low-intensity sheep-grazed area, we bring acid grassland back in, because remember that we had some species that were found only in that acid grassland. So we took this whole body of work and put it in the context of the literature, and then produced this document which translated research into practice. So we worked with lots of conservation bodies and really closely with Natural England to look at how you might manage upland calcareous grasslands from a ground beetle and a spider perspective. And if anyone wants it, it's available for free on that link just there. Okay, so if I can sit in Britain and have a traditional Sunday roast, I can also sit in Germany and have a traditional Sunday roast. So for anyone who doesn't speak German, that just says exactly the same thing as it did in English. So remembering in Germany, they have the same sort of extent of calcareous grassland in the UK, but this time it's spread over way more sites. And that means that lots of these calcareous grasslands are often less than 1 hectare in size, so really tiny. And that sort of brings some problems in itself. And actually, Germany faced decline and about 60% loss of calcareous grasslands in the 20th century. But this time, often it was due to a lack of grazing, so the opposite of what happened over in Britain. And this lack of grazing was caused in part by the UK and also by Sunday roast preferences over in Germany. So in the 50s, the UK guaranteed wool prices. This meant that the UK got lots of money for the sheep, but in Germany, these sheep prices actually dropped. And that meant that sheep farming wasn't competitive anymore. So the national sheep flock fell from 30 million to less than 1 million by the 1960s. Now, this created some issues. We had abandonment because we had no grazing animals, which resulted in succession. And actually, this photo shows those successional processes really well. So in the foreground here, we've got the calcareous grassland, then we've got this scrub encroachment, and then reversion to beech forest. And then in the distance, we can see that agricultural intensification of arable farming, which surrounds all of these grassland patches. And that led to fragmentation and a decrease in size of these areas. This was compounded by more infrastructure coming in and by urbanisation encroaching, which meant that there was an increased administrative effort in order to try and conserve any of these areas, coupled with a lack of resources, so a lack of grazing animals and a lack of money for conservation, makes this loop carry on going round and round and round. And actually, the figure of extent is probably reduced now, as time has gone by. So the real issues there are Sunday roast preferences. Pork is the most popular meat in Germany. So when they're roasting it, they'd rather have pork. They don't eat much lamb at all. So there's not much demand for, the national flock increasing to what it was. So actually, it increased to around about 2.7 million by 2002. But it's currently at around about 1.5 million sheep, and it's been there steadily for the last 6 or 7 years. So the real issues in Germany are isolation, fragmentation, and a lack of resources. So we wanted to investigate that. So within 31 calcareous grassland areas in central Germany, we looked at how butterflies respond to habitat size, connectivity, and landscape context. We actually looked at a number of taxonomic groups, but I've pulled that out for the interest of this conference today. So we asked a couple of questions. Which environmental variables influence local patterns of diversity, and which spatial scale of landscape composition impacts local patterns of butterfly diversity? So what we did was we looked at patch size. So our small patches were those of less than 1 hectare. Our medium patches were between 1 and 3 hectares, and our large ones were sometimes really huge at like 5.5 hectares. And then we looked at metrics of connectivity, so how far away were these patches from each other and from interesting areas of grassland. And then we looked at succession, so we rated this on a scale of 1 to 4. Number 1 being open and number 4 being it's become a beech woodland. And then we looked at the percent cover of arable land surrounding each of these grassland types at 250-metre increments. And then when we looked at this on a landscape scale, we increased those 250-metre increments up to 3 kilometres away from these grassland patches. And we found some interesting things. We found that species composition was more variable within small fragments, so that old adage of, several small or one large in terms of accumulation of species richness and composition. So this is the greyed out area. So small fragments are more different from each other. We found that small fragments in terms of species composition differed mostly from large fragments, but the relationship wasn't quite statistically significant, but there's some sort of divergence happening there. We found that species composition of butterflies was significantly related to the percent cover of arable land within the surrounding 250 metres, and also to the successional stage in the grassland, rather than how close or far apart or the size of those grasslands. And we found that where you had increased percent cover of arable land, we have fewer grassland specialists in that composition. Okay, so if we're considering management in Germany, the things we need to think of are there's a lack of resources, so any conservation management you do has to be really targeted. Grazing isn't economically viable on small patches. The successional stage within those grassland fragments influences composition, and patches with less arable land within 250 metres have more specialist species and distinct communities. So in terms of recommending things for management, we say choose large areas if you have to choose. Choose large areas that have a lower proportion of arable land within 250 metres. And think about successional processes. If you can choose places that are still open, go for them. If you've got the resources available in these large patches, can you reverse that succession? So start taking out some of that scrub. And that's a lot. Thank you very much. And I'd just like to say before I finish, thanks so much for having me. And thanks, Anya and Brian, for an incredible trip to the Burren and giving me an excuse to come here.
Great. We have a few minutes for questions, so I'll give people in the room a first shot before I have a check online. Yeah, Tom. Oh, sorry.
I was wondering if you looked at the effect of different patterns of dunging in different types of grassland management on, because cattle, for example, will have dung in areas, especially when they're grazed at low intensity, and then that area won't be grazed by the cattle, so you'll get a different vegetation structure there, where sheep will have more kind of evenly dispersed.
Yeah, absolutely. No, we didn't. We were really conscious when we placed our sampling areas to try and pick areas that were most typical of those grassland types. And actually we had very little dungan within our quadrats over time. But yeah, it's quite clear that, you know, a cow pat does something different to the vegetation structure than sheep dung does. So yeah, it would be really interesting to get, you know, more in-depth knowledge. And also remembering that these calcareous grasslands aren't just lovely sweet calcareous grasslands, there's other patches as well. So calculation of grazing intensity really should take into the proportion, you know, where are these animals spending time, and then, you know, from that, trying to work out conservation grazing types. But no, we didn't take into account dungan. That would make a lovely next study.
Any other questions in the room? Anyone there online, Anya?
No, quite.
Okay, so, yeah, Maria. Roy, can you pass that back behind you, please? There. Yeah.
Thanks a million. Ashley, you should get a prize for most amount of research studies presented in a short talk. It was great. And clearly, so you did really well. Just a kind of a question. It's interesting that you have the German perspective as well. And I just wondered, did you notice, or was there an influence of land ownership patterns? Because one of the things I did when I started work as a grassland ecologist, it just happened that I went to France for a conference about, for grassland managers, and it was just so completely different. There were small patches of publicly owned grasslands, and the public authority owned herds and moved them around to graze them. They couldn't believe we actually had farmers. So just wonder, how does the land ownership and the land management and the ownership of the animals as well influence, you know, the big picture?
It's a good question. It's in Germany, or at least that part of Germany I was in, seems to be completely sporadic. And different people do different things, and you couldn't assess different grazing types in these areas because it's all completely different. Sometimes it's donkeys, sometimes it's goats, sometimes it's sheep, sometimes no one knows what's going on. But those areas that are definitely grazed definitely look better than those areas where we've run out of resource and the local authority doesn't have that resource. So often it's a case of trying to get volunteer farmers to come and graze a patch for however long. And it really strikes me, walking around yesterday, some of the similarities you see in these German landscapes to the Burren landscapes. And I absolutely must urge, do not lose the grazing animals from the Burren. I mean, when you graze and how much you graze is another question. But you can start to see like those similarities in the grasslands where you have intermediate succession in Germany, and then you can see actually that next grassland there has become this beech woodland, which you're not going to get there, but you get, you know, something different. And for them, losing that resource of being able to stop that happening was something that's been massively detrimental. So, I mean, yeah, if you want a similarity, go to central Germany, don't go to Britain. It's mostly a treeless landscape. I mean, if you find one tree, it's really exciting. But yeah, definitely similarities between the two places.
Yeah, good question here from Claire Hamilton. Can other animals, horses or donkeys, etc., be used for light grazing? So she's asking more from the point of view of a hobby farmer or a casual landowner.
Yeah, so certainly, again, it's not something that we addressed in this study, so I'm not necessarily expert on that. But yeah, the thing to remember is basically teeth are really important. So the way that the dentiture is made up of the animal impacts how they graze and the vegetation and what have you. So, you know, horses, you'll often find latrine areas and really cropped areas. You get the same with rabbits. You know, they'll tend to focus on shorter areas. So, yeah, but it depends what you want from your conservation management is my answer to that question.
One last one from Jessica. Ashley, thank you for a wonderful presentation. It's fascinating by it. Butterfly Conservation Europe held a conference earlier this year, and one of the statistics given was that in protected areas in Western Germany, there was a 75% decline in insect biomass in the 27 years up to 2017, which really sounds devastating. What's going wrong there? One of the German delegates described the situation in Germany as just appalling.
Yeah, but arable farming, it would be my best guess. So when you go to these areas, there's fabulous grassland, and then you get through the scrub and you get through the beech woodland, and then as far as you can see, it's a landscape. It looks like a patchwork quilt. You know, so a lot of the time that's bare soil, sometimes it's monoculture crop, but my best guess would be, you know, like everywhere, arable farming, intensification, use of nitrogen fertilizers, pesticides.
So problems that we have throughout Europe.
Oh yeah, you can't say in Germany it's any different to anywhere else. I mean, they're doing nothing more worse than we are over in Britain. Yeah, it's but a really interesting landscape to see, because in a very close area you see all of those things, and you know, people need to eat and economies need to go on. So it's not my place to say, really, you know.
Thanks, Ashley. Thank you.
Thank you.
That's great.
Thank you.